Hello students, welcome to the interesting chemistry where you will find an atmosphere of classroom teaching. If you want to enjoy a classroom teaching experience from your study room, then please watch my video of interesting chemistry. Today I am going to explain you the most important topic, that is limiting reagents. This limiting reagent is related to the chemical reactions. As you know, there are two things in a chemical reaction. One is reactant and second one is product. So mostly this limiting reagent is related to the reactants. It means it's a chemical compound which takes part in a chemical reaction. So how will this one reactant is called a limiting reagent? I am going to explain you. For example, if you have a reaction in chemical reaction in which only one reactant is taking part. For example, this calcium carbonate. When calcium carbonate is heated, it will decompose into this CaO and CO2. The decomposition of calcium carbonate will take place independently. The reactant reacts independently. There is no any other reactant to interfere the decomposition of this calcium carbonate. So the total amount of the calcium carbonate which is taken in the chemical reaction will be converted into product, or when the total amount of reactants is converted into the products, that reaction called as a perfect reaction. Perfect chemical reaction. But when there are two or more reactants in a chemical reaction, then the amount of one reactant will create its effect on the other reactant. As in case of when CaCO3 is treated with HCl, it gives CaCl2, H2O and CO2. For example, in your practical you have taken, this is the test tube and you have taken this amount of calcium carbonate, this amount of calcium carbonate, this is calcium carbonate, and you have a drop, 5 drops of HCl. This is the amount of calcium carbonate, and you added the 5 drops of calcium HCl. What will happen? A small amount of carbon dioxide will be formed. First thing. Second, the 5 drops of HCl will be consumed immediately, hence the further reaction won't take place. And lastly, the amount of calcium carbonate will remain unreacted. So this experiment or this chemical reaction which I have shown you is an imperfect reaction. Imperfect reaction means the reaction in which the total amount of the reactants doesn't convert into the products. So now why it is so? Why this has happened? Because generally we take the amount of reactants in a chemical reaction randomly without any measurement. That's why the reaction is called as imperfect chemical reaction. But for the perfect chemical reaction, you should take the amount according to the balanced chemical equation, or you can say the amount of the reactants must be taken as required by the balanced chemical equation, because the balanced chemical equation tells about the all stoichiometric information of that reaction. Here in this case, 1 mole of calcium carbonate and 2 mole of calcium reaction on mole, so you know very well. Again, this mole is converted to this mole is equal to the 1 mole equal to the 100 gram. This 1 mole of HCl is equal to 36.5 and 2 into 30 gram. So when 100 gram of calcium carbonate is treated with 73 gram of HCl, it will give the such amount of the calcium carbonate H2 and CO2. But now, if I ask you, when I have taken 100 gram of calcium carbonate and only 36.5, the requirement is 73 gram, but I have taken 36.5 gram of the HCl. What will happen? This HCl will be consumed first, and calcium carbonate will remain, some amount of the calcium carbonate remains unreacted. The sum of the amount of calcium carbonate is left unreacted, so it is the imperfect reaction. But here again you can tell me that it is just half amount of this 73 gram. 36 point is the half of the 73 gram. So it is half of the calcium carbonate will be react with this, and half more and half more and half more amount of the calcium carbonate, and 50 gram of the calcium carbonate is left unreacted in this reaction. So this again, the less amount of the calcium carbonate shows here, it limits the production of the reaction, so it will be called as limiting reagent. Here, when you take this amount 36.5 gram, if you take the amount 6, according to the balanced chemical equation, it will not be a limiting reagent. But if you take the amount 36.5 or less amount than 73 gram, it is called the limiting reagent. Suppose here, I have taken the example for you that this one, when AB reacts to form AB, if you take 10 more molecules, I have taken here molecules, 10 molecules of A and 8 molecules of B, how many molecules of AB will be formed? Because there 8, here the requirement is here 1:1. The stoichiometric ratio of this reactant shows us 1:1. So this 8 molecule of B will react with 8 molecule of A. Then the 8 molecule of AB will be formed. So again here, after consuming the 8 molecule of B, 8 molecules of B, the reaction will be stopped. No further reaction will take place. And the amount of A will be left here, 2 molecules is left unreacted. Only 8 molecule will take part in this reaction, and 8 molecule of AB will be formed. If I reverse the reaction, then 8 molecules and 10 molecules, again it will be 8 molecules. But for example, this B is limiting reagent because the amount of B is less here. It consumed first here, and in second example, the amount is less here, 8. So A will be the limiting reagent because it consumed first, and further reaction won't take place. Again here, when A plus 2B reacts with to form AB2. Here again, this 8 molecules of A and 10 molecules of B. Here I told you this 8 was due to the 8 molecule, due to the less amount of this A is a here in this case A is a limiting reagent, but here decide who is limiting reagent. If you only think that the less amount, the reactant that has the less amount will be called as limiting reagent. No, that is not correct. Here think about here. The 8 molecules, how many molecules AB2 will be formed? How will you tell you? Here again, 2 molecules of B require 1 molecule of A, and 10 molecules of B will require 1 by 2 into 5. So the 5 molecules will react with 10 molecules of B. So it will be only 5 molecules. 5 molecules of AB will be formed here, and 3 molecules will left unreacted A. So here, despite having the more amount of B here, it is again this B is a limiting reagent in this case. So this is how. So now I am telling you that how will you decide? How will you decide the limiting reagent in that case? Suppose here I have given you a example. Here I have written the decision. Here 250 grams of calcium carbonate. Please write this question. 250 gram of calcium carbonate when treated with 164.25 gram of HCl, which reactant is limiting reagent, or find out the limiting reagent in that case. And second, which one, how much amount of CO2 will be formed? 2 questions. You have to answer 2 things. One is limiting reagent, and second one is amount of CO2. The amount of CO2. So what amount of CO2 will be formed from here? So again, this I am telling you how will you decide the limiting reagent. In your question, the amount will be given in the gram. So gram amount will not decide, won't help to decide the limiting reagent. Only this mole unit helps you to decide the limiting reagent. So this gram amount of the calcium carbonate and HCl must be converted into mole. So divide by this with 100. So here 2.5 mole of calcium carbonate, and here when you divide this, the HCl, the 1 mole of HCl is equal to 30.6.5. So you will divide here 36.5. It will be the 4.5 mole. Again here, it is 2.5 mole and it is 4.5 mole. Again here the amount is more of the HCl and amount is less in calcium carbonate. So don't say that it is, please again calculate it. Which one is limiting factor? Here 1 mole of, this is the ratio. 1 mole CaCO3 requires 2 mole HCl. 2 mole HCl. 2 mole HCl. 2 mole HCl. So here how many moles of the calcium carbonate is here? 1 mole of CaCO3 requires 2 mole, and here you have 2.5 mole. So 2.5 mole will require 2 into 2.5 mole. So the total requirement of the HCl is 5 mole, and you have only 4.5 mole. What will happen? This will be consumed first, because 2.5 mole of calcium carbonate requires 5 mole of the HCl. So and here in your experiment you have only 4.5 mole of the HCl. So it will be the consumed first. So this HCl will act as a limiting reagent. I think that you have understood about this method. Now the question arises: what amount of CO2 will be formed? So actually, which reactant is consumed totally? This 4.5 mole of the 4.5 mole of HCl consumed first. So according to this amount, this carbon dioxide will be formed. So again, calculate the amount of carbon dioxide. How will you calculate the amount of carbon dioxide? I will tell you that the 2 mole HCl produces 1 mole of CO2. Here 2 mole. This again, take this stoichiometric value from this 2 mole of carbon dioxide. HCl forms 1 mole of CO2. And how many moles are there in 4.5? So 1 by 2 and 4.5 is equal to 2.25 mole of carbon dioxide will be formed. 2.4. Now 2.4. Again, these are the mole, and 1 mole is equal to 44. Then 44 into 2.24. That will be your answer. In this way, you can solve this answer. I think that you have understood. For this example, I will give you 2 more examples, 2 more numericals. I am going to 2 numericals are for you. First numerical is that when 49 gram of CS2 or ethene is treated with 3.2 gram of hydrogen, what amount of ethane will be formed, and also decide the limiting factor in this chemical reaction. To solve this chemical reaction, first of all, you have to write the balanced chemical equation. This is the balanced chemical equation, and this one is the stoichiometric coefficient of this reaction. So again, and now write down the amount: 49 gram of ethene and 3.2. This amount is taken by you in this reaction. This is the required amount, and this is the taken amount. This is required, and this is taken amount. So relate to this. Both the amounts should be related with each other. First of all, this is mole, and here it is gram. So change this amount in mole. How will you change? Gram, when gram is divided by the molar mass of ethene, 24 plus 4 is equal to 28, and this 28, this will equal to the value 7 and 4. This is 1.75 mole. So 49 gram of ethene is equal to 1.75 mole, and 0.32 gram is equal to 1.6 gram. So divide by 2 and gram of hydrogen. this is the amount we have taken, and the requirement is 1 mole reacts with 1 mole, and here 1.75 mole will react with 1.75 mole. So here again you will say that 1.5, 1.6 and this 1.6. So 1.6 mole, 1.75 mole of CS2 will require 1.7.5 mole of hydrogen. This is the question. Because 1 mole requires 1 mole, so 1.75 mole of ethene will require 1.7 mole of hydrogen, and you have 1.6 mole of hydrogen, actually taken amount. So this hydrogen is a limiting factor in this case, because it will consume first. It will consume. As I told you in my previous slide, I forgot to tell you the definition of the limiting reagent. I have written in this slide. Please pause that video and note that the definition of the limiting reagent, the reactant which gets consumed first and limits the amount of product is called limiting factor. I have written in this slide. Please pause this video, this video. So here the 1.75 mole of ethane requires 1.7 mole of hydrogen, but in actual from this stoichiometric ratio you calculated 1.75 mole of hydrogen will require 1.75 mole of hydrogen, but you have 1.6 mole of hydrogen. So the hydrogen is a limiting factor. So when the limiting factor consumed first, so the product will be formed according to the limiting reagent. Not for this amount is in excess, this amount is less. So when 1.6 gram of hydrogen is consumed, then the amount of methane will not form after consuming the 1.6 gram of hydrogen. So 1.6 gram. So actually the 1.6 mole plus 0.15 mole of ethene here, CS2 double bond CS2. This 1.75 is equal to 1.6 and 1.15 plus 1.6 mole of hydrogen. So this 1.6 will consume this 1.5. This 1.5 mole of CS2 remain unreacted, and this 1. So this ethene will be formed 1.6 mole of ethane. This ethane will be formed 1.6. Now you have to tell this the 1.6. What will the 1.6 into 40 and 6 into 30? So the 48 gram of ethane will be formed. This was about this numerical. Please don't go to my handwriting. I think that you have understood about this numerical. How will you solve this numerical? Next numerical. Write down the numerical. The 56 kg of nitrogen is treated with 10 kg of hydrogen. What amount of ammonia will be formed in this reaction, and also decide the limiting factor. So I think you have written this reaction is nitrogen plus 3s2 hydrogen and 2ns3. It's a Haber-Vidhi to form the ammonia 2ns3. So 1 mole, 3 mole and 2 mole of ammonia formed in this reaction. This is the required amount for this reaction. The required amount for this reaction, you have noted it from the balanced chemical equation. This is required for the product. Now you have the taken amount. Taken amount is, suppose here taken amount is 56 kg. 56 kg of ammonia, nitrogen, and 10 kg of hydrogen. What will be the amount of fluid formed? It is the question. Now I have given 56 into 10 raised to the power 3 gram. 10 into 10 raised to the power 3 gram. What about the, now you have to change this gram amount into mole. So again you will divide it by 28 because the molecular mass of nitrogen is 8 and the molecular mass of hydrogen is 2. So this 2 into 10 raised to the power 23 mole of nitrogen and 5 mole of hydrogen. You have taken 5 into 10 raised to the power 3 mole of hydrogen. This is the taken amount. Taken amount and required amount. Now you have to compare this amount with this amount. Here, now think about it. 1 mole of nitrogen, 1 mole of nitrogen requires 3 mole hydrogen. 1 mole of nitrogen requires 3 mole hydrogen, required amount. And how many, what amount you have of nitrogen? So 2 mole. So the 2 mole of nitrogen will require 2 into 3 is equal to 6 mole of hydrogen. So the requirement is for, according to this 2 mole, you have 2 mole of nitrogen. So 2 mole of nitrogen will require 6 mole of hydrogen. So here again the 2, you will write here 10 to the raised power 6 or 6 into 10 raised power 3. So 6 into 10 raised to power 3 moles of hydrogen by multiplying this 3. So here you have only 5 moles. So this hydrogen is a limiting reagent. This is a limiting reagent. Now only the ammonia will be formed on behalf of this 5 mole of hydrogen. Because the 5 mole of hydrogen has to form the ammonia. After 5 moles consuming the 5 moles of hydrogen, the formation ammonia will be stopped. So again take here 3 mole of hydrogen forms 2 mole ammonia. 2 mole of ammonia. And you have only 5 moles. So the 1 mole will form 2 upon 3 and 5 into 10 raised to the power 3 will form 5 into 10 raised to the power 3. So it will 10 by 3 into 10 raised to the power 3. So again it is 3 by 3 into 10 raised to the power 3 gram, and you will write here 3.3 kg. It will be the answer. So the answer for this question, the hydrogen is the limiting factor in this case, and the total amount of ammonia will be formed the 3.3 of this here. 5 into 10 upon 10, 10 is 3.3 kg. I think that you have understood both the numerical. Please, at the last, like it and share it, this video, and also write your comment if I can improve my way of teaching to make you more understand. So that's all for today. Thank you very much.